On a hot, humid Australian afternoon, a harmless-looking cloud can grow into a thunderstorm, dump rain on one suburb, and be gone before the next forecast update. That is the nature of a single-cell thunderstorm, also called an air mass thunderstorm. It is small, short-lived, and usually driven by local heating rather than a major front. The basic setup is simple. The sun heats the ground heats moist air near the surface, and that warm air rises. If the atmosphere is unstable enough, the rising air keeps climbing, cools and condenses into a towering cumulus cloud. Because the winds do not change much with height, the storm is not tilted or organized like a supercell. It has one main updraft and, later, one main downdraft. Meteorologists describe the life cycle in 3 stages. The first is the developing stage. This is when the updraft is strongest and the cloud grows vertically. There may be no rain yet, but the cloud top can build quickly, especially over hot inland areas, coastal sea breeze boundaries, or tropical islands north of Darwin. The second stage is the mature stage, and this is when the storm becomes most dangerous. Water droplets and ice particles become too heavy for the updraft to hold. Rain begins to fall, dragging cooler air down with it. Lightning, brief heavy rain, small hail, and sudden gusty winds are most likely now. In strong pulses, lightning rates can become extreme, and a gust front can surge away from the storm, with winds over 70 kilometers an hour. The third stage is dissipation. In weak wind shear, the falling rain drops straight back through the rising warm air. The downdraft cuts off the storm's fuel supply, a bit like the storm choking on its own exhaust. Dry air mixes in, evaporation cools the downdraft further, and the cloud rapidly weakens into ragged leftovers and high ice cloud. Most single-cell storms last around 30 minutes to 1 hour, with the most active burst often only 15 to 20 minutes. That short life is why they are sometimes called pulse storms. They fire up quickly, peak hard, and collapse just as quickly. In Australia, they are common in summer. You can see them along the Great Dividing Range, around Brisbane and Sydney, across inland plains, and through the top end when heat and moisture are plentiful. Hector the Convector, the famous regular storm near the Tiwi Islands, shows how sea breezes can focus rising air in the same place again and again. On radar, a single cell often appears as a compact spot of stronger reflectivity rather than a long line or rotating structure. Forecasters watch for sudden spikes as the updraft strengthens, but predicting the exact suburb that gets hit can be difficult. One street may see sunshine, while the next suburb gets a burst of rain, lightning, and wind. These storms are usually less severe than supercells, but they are not harmless. Lightning can strike well away from the heaviest rain. Slow movement can cause quick street flooding. On the water, a fast wind shift from the downdraft can be dangerous for small boats. If you see a towering cumulus cloud growing fast, darkening underneath, and losing its crisp edges, it is time to move to shelter. The key lesson is that isolated does not mean safe. A single-cell thunderstorm may be brief and local, but for the people directly underneath it, the impacts can be sudden, intense, and serious.